Creating millions of identical, perfectly curved chips at lightning speed seems impossible, but Pringles factories do it every single day. Using a process unlike any other snack, these chips aren't sliced from potatoes, but engineered from a precise formula to achieve their signature crunch. Today, we take you behind the scenes of the Pringles production line, from dough preparation to frying and packaging. Let's uncover the mind-blowing science behind the world's most famous chips. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High-starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure, while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical, as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because over-drying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. The company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, three factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. The production of Cheetos begins not with cheese or seasoning, but with one humble ingredient: corn. In fact, the specific type of corn used in Cheetos manufacturing is carefully selected and processed to meet exacting technical standards before it even enters the plant. The base product of every Cheeto is degermed cornmeal, derived from a variety of field corn that is specially cultivated for its high starch content and low fat levels. This corn must produce a uniform, predictable puff when subjected to extreme heat and pressure, so its density, moisture content, and kernel hardness are closely monitored even at the agricultural stage. Farmers contracted by the manufacturer are required to meet tight tolerances in grain quality, harvesting methods, and post-harvest drying to ensure the raw corn will meet the standards for industrial puffed snack production. Once harvested and transported to the ingredient supplier, the corn undergoes an initial cleaning to remove plant debris, soil, and foreign materials. It is then taken through a degermination process, in which the outer bran layer and the germ, the oil-rich, nutrient-dense part of the corn kernel, are removed. This step is essential. While germ and bran contain healthy fats and proteins, their presence can negatively impact the expansion properties and shelf life of the final product. Germ oil can go rancid over time and interfere with the consistent puff structure that defines a Cheeto. What remains after degermination is the starchy endosperm, milled down into a fine cornmeal that becomes the building block of every puff. This cornmeal is then enriched with a blend of vitamins and minerals, including riboflavin, niacin, iron, and folic acid. The enrichment not only helps meet nutritional labeling requirements, but also contributes to uniformity in the extrusion process, as these additives influence how the mixture reacts under heat and pressure. The resulting product is a dry, golden yellow flour with a specific granulation profile tailored to the plant's extrusion parameters. Before it is used on the production line, the cornmeal is stored in temperature and humidity-controlled silos directly connected to the processing plant. These silos often hold hundreds of metric tons of product and are designed to keep the cornmeal in a stable state for extended periods. Pneumatic systems transfer the cornmeal through stainless steel pipelines to weigh hoppers on the factory floor, where batch sizes are precisely measured. Real-time inventory sensors track the flow of material and communicate with the factory's central control system to automatically replenish supply lines as needed, ensuring uninterrupted production. Now it's time for the first transformation phase: hydration and preconditioning. The cornmeal is metered into a continuous mixing system where it is blended with water or steam to raise its moisture content to a narrowly specified range, usually between 15% and 20%. This step is essential to prepare the starch molecules for gelatinization. The equipment used here is not unlike a ribbon blender or paddle mixer, which agitates the mixture thoroughly to ensure every granule of cornmeal is evenly hydrated. Water is introduced through atomizing nozzles positioned at calculated intervals along the mixer's length, and multiple moisture sensors along the pathway feed back to the PLC system to adjust water input in real time. This moist mixture, often referred to as dough, despite its loose, crumbly texture, is held briefly in a conditioning tank to allow for even moisture distribution. The temperature and residence time are carefully controlled. If the mix is too hot or too wet, it may pre-gelatinize and clog the extruder. Too dry, and it won't expand properly. During this stage, the product is slowly moved along a jacketed screw conveyor that maintains a consistent temperature and prevents clumping. Now we arrive at the heart of the production line, the extruder. Industrial Cheetos are made using a twin screw extruder, one of the most sophisticated and critical machines in the plant. The twin screw configuration allows for highly controlled processing of the corn mixture, providing better mixing, higher shear, and superior control over temperature and pressure compared to single screw models. The hydrated cornmeal is fed into the extruder barrel, where it encounters two rotating screws that convey the material forward under intense mechanical pressure. External heaters line the barrel and raise the temperature incrementally as the product moves through each zone. Inside, shear forces generated by the screws convert some of this mechanical energy into heat, further increasing the temperature of the dough. The intense conditions inside the extruder, pressure in the range of 200 to 500 psi, and temperatures from 130 degrees Celsius to 180 degrees Celsius, cause the starches in the cornmeal to gelatinize and the water to superheat. The dough undergoes plasticization, becoming a molten mass under pressure. As this molten dough reaches the end of the barrel, it is forced through a die, the precision-crafted metal plate that defines the shape of the puff. The die hole is round and small, but as the dough exits into atmospheric pressure, the superheated water in the mixture flashes into steam, causing the structure to puff and expand dramatically in a fraction of a second. This rapid expansion is responsible for the iconic airy texture of a Cheeto. Just outside the die, rotating knives spin at high speed, slicing the continuous stream of puff into uniformly sized segments. The speed of the knives determines the length of the puff, while the pressure and temperature within the extruder affect its diameter and density. But even after this high-tech transformation, the newly extruded Cheetos are far from finished. They are still pale, moist, and bland, essentially unseasoned corn puffs. The next stage is all about turning them into the crunchy, craveable snack that consumers instantly recognize. First, the extruded pieces are conveyed via vibrating trays to a frying system. Here, they're submerged in hot oil, typically corn or canola oil, at carefully controlled temperatures ranging between 160 degrees Celsius and 180 degrees Celsius. The residence time in the fryer is only about 20 to 40 seconds, but in that time, the moisture content is reduced dramatically from around 15% to under 2%. This not only creates the final crispy texture, but also deepens the color slightly, giving the snack its characteristic golden hue. The fryer itself is a marvel of engineering, equipped with multiple sensors and filtration systems. Oil turnover rates are high, meaning that fresh oil is constantly added, while spent oil is removed and filtered to maintain quality. Skimmers remove any floating particles, and oil chemistry is monitored for signs of oxidation, free fatty acid levels, and polymerization. If any readings fall outside of the strict parameters, the fryer automatically triggers corrective actions, dosing with fresh oil, increasing filtration, or even pausing the line to prevent compromised batches from continuing downstream. After exiting the fryer, the Cheetos are carried on mesh conveyors through an air cooling tunnel. High-powered fans blow ambient or conditioned air over the freshly fried snacks, bringing them to a safe handling temperature and ensuring any surface oil solidifies just slightly to help the seasoning adhere. These cooling conveyors are extended and designed with soft vibratory motion to prevent breakage, ensuring that the delicate puffs remain intact before entering the seasoning phase. Next, the Cheetos are transferred into a massive rotating flavor drum, where their bland exterior is transformed by a shower of powdered cheese blend. But before we dive into the complexities of seasoning, we'll need to explore how oil coating is applied for adhesion, and how powder distribution systems are calibrated to ensure every single puff gets the perfect amount of flavoring. This next part of the production process is where precision meets sensory science, and the result is the addictively cheesy snack that has become a global favorite. Now it's time to dive into one of the most iconic and intricate stages in Cheetos manufacturing, the flavoring phase. This is where the bland, puffed, and fried corn kernels are transformed into the intensely savory, cheese-coated snacks recognized all over the world. The process of seasoning Cheetos is not merely about tossing on a bit of cheese powder. It is an engineered, tightly controlled operation that determines product consistency, taste balance, visual appeal, and even mouthfeel. Everything from the size and porosity of the puff to the electrostatic charge of the powder particles is taken into account in this phase. After exiting the cooling conveyor from the fryer, the puffs are transferred into large rotating cylindrical drums called flavor tumblers. These drums are typically positioned on a gentle incline and rotate slowly, creating a continuous cascade of puffs inside the drum that exposes every surface area of each piece as they tumble forward. This mechanical tumbling is crucial. It ensures an even coating without crushing the fragile, aerated product. Inside the drum, two key applications occur almost simultaneously. First, a fine mist of oil is sprayed onto the hot puffs. Then, a controlled stream of seasoning powder is dispensed over the tumbling mass. The oil, which is typically a neutral vegetable oil like corn or canola, plays several roles in this step. Primarily, it acts as an adhesive layer that allows the seasoning powder to stick effectively to the puff's surface. Additionally, it helps activate the flavor compounds in the powder blend, carrying volatile aroma molecules and enhancing taste perception. The oil spray system uses ultra-fine atomizing nozzles that are precisely calibrated to deliver a uniform coat without oversaturation. Too much oil, and the puffs become greasy and soggy. Too little, and the powder won't adhere properly, leading to uneven seasoning distribution and flavorless bites. The timing, angle, and rate of oil application are closely monitored and adjusted by sensors and programmable logic controllers. Real-time feedback systems measure oil usage, droplet size, and the thermal signature of the puffs to ensure that coating is optimal under varying production speeds or ambient conditions. This level of automation ensures consistency across thousands of pounds of product produced per hour. As the puffs are coated in oil, the seasoning powder is introduced using a vibratory feeder or screw conveyor system. The powder is held in a hopper mounted above the flavor drum and is dispensed through controlled openings at a fixed rate, matched to the flow of puffs. The exact dosing rate depends on the type of Cheetos being produced. Flamin' Hot varieties require slightly more powder per unit than the traditional cheese puffs due to differences in density, powder, granularity, and flavor intensity. The seasoning blend itself is a complex formulation engineered not only for taste, but also for flow characteristics, adhesion, and shelf stability. The base of the powder is often dehydrated cheddar cheese, spray-dried into a fine particle form. This is combined with whey or whey protein concentrate, maltodextrin, salt, monosodium glutamate, MSG, disodium phosphate, citric acid, and natural or artificial flavors. Each of these ingredients plays a very specific role. Maltodextrin, for example, acts as a carrier and anti-caking agent that helps the powder distribute evenly and resist clumping. Citric acid provides a tangy bite that enhances cheese flavor. MSG boosts umami and deepens savory perception. Color additives like annatto or oleoresin paprika for classic cheese and red 40 or yellow 6 for Flamin' Hot are oil dispersible pigments that give the snack its vivid appearance without creating spotting or streaks. The particle size distribution of the powder is engineered to align with the surface texture of the puffed snack. Powder that's too coarse will fall off, and powder that's too fine will clump or create an overly dusty texture. To prevent powder fallout, electrostatic systems are sometimes used in high-speed lines. In these cases, the powder is given a minor static charge to improve its affinity for the puff surface, minimizing waste and improving adhesion. Inside the flavor tumbler, the balance of oil spray and powder distribution creates a beautiful, uniform layer of seasoning that fully coats each puff without pooling at the bottom of the drum or leaving bald spots on the product. The drum's internal design is key. Angled baffles gently lift and drop the puffs to keep them moving without subjecting them to mechanical stress. As the snacks make their way to the end of the drum, they are now visually and sensorially transformed. Bright orange, evenly coated, and bursting with aroma. Once the seasoning phase is complete, the fully flavored Cheetos are gently transitioned to the final conveyor belt systems that lead to the packaging area. Here, another series of quality control measures come into play. Inline camera systems inspect color uniformity and powder coverage using advanced image recognition algorithms. If a section of the product stream is detected to have an irregular appearance, whether due to light seasoning, overcoating, or discoloration, it is flagged and diverted from the main line for manual inspection or disposal. At this point, the Cheetos are still vulnerable to moisture pickup, oxidation, and mechanical damage, so the packaging process must move swiftly and with precision. The conveyor system delivers the finished puffs to a multi-head weigher mounted above the bagging machines. This machine uses multiple weigh hoppers to rapidly measure exact product portions, typically in the range of 28 g to 250 g per serving, depending on the bag size. These weighers use real-time load cell feedback to select the optimal combination of buckets to match the target weight, within a tolerance as tight as +2G. Each pre-measured portion is released down a chute into a vertical form-fill seal (VFFS) machine. These machines work by pulling a flat roll of pre-printed film through a collar that forms it into a tube. The bottom of the tube is heat sealed to create the first seam, the Cheetos are dropped in, and then the top is sealed and cut, simultaneously forming the bottom seal of the next bag in line. These machines can fill and seal over 100 bags per minute per lane, and multiple lanes often run in parallel for large-scale production. The film used for the packaging is multi-layered and engineered to provide barrier protection against light, oxygen, and moisture. It typically includes an outer polyester film for print quality and visual appeal, a middle layer of aluminum or metallized polypropylene for oxygen and light resistance, and an inner polyethylene layer for heat sealing and moisture resistance. As each bag is sealed, a date code, batch number, and factory identifier are printed using high-speed inkjet printers for traceability. Just after sealing, every bag passes through a series of checkpoints. Metal detectors scan for any foreign objects, vision systems verify print alignment and code readability, and weight checkers ensure compliance with regulatory standards. Non-conforming bags are automatically ejected onto a rejection conveyor, where they are set aside for manual inspection. Approved bags are then grouped and packed into cardboard shipping cartons by robotic pick-and-place systems or automated drop packers. These cartons are sealed, barcoded, and routed to the palletizing station. Here, industrial robotic arms stack the cartons onto wooden or plastic pallets using optimized patterns for stability and load balance. As each pallet is completed, it is wrapped in stretch film to secure the load and protect it from dust and humidity during storage and transportation. The palletized loads are then scanned into the plant's warehouse management system, which tracks location, batch status, and distribution destination. Some pallets are moved to ambient storage if they are designated for short-haul routes, while others are transported to climate-controlled storage areas that maintain low humidity and consistent temperatures, ensuring that the product maintains its texture and flavor until it reaches its final destination. What follows is the outbound logistics phase, where the pallets are loaded onto trucks, routed to distribution centers, and delivered to retailers. But for now, every step inside the production facility, from the moment the cornmeal is hydrated to the final bag, passing the last inspection point, has been a meticulously engineered series of chemical, mechanical, and sensory transformations. Every component of the Cheetos production line is designed not just for efficiency and speed, but to deliver a reliably indulgent experience in every bag. And it all happens in a continuous, automated, high-output environment that must maintain exacting standards of quality, cleanliness, and consistency hour after hour, shift after shift. One of the key operational pillars at this stage is environmental control. Temperature, humidity, and airflow within the production zones are tightly monitored and controlled around the clock. Cheetos, especially after frying and seasoning, are highly sensitive to ambient conditions. If the air in the seasoning or packaging area carries too much humidity, for instance, the cheese powder may begin to clump, reducing its dispersibility and leading to uneven coating. Worse still, excess moisture can cause the puffs to begin absorbing water from the air, softening the texture and compromising the crisp, dry bite expected by consumers. To prevent these issues, HVAC systems specifically engineered for food processing environments are deployed throughout the Cheetos plant. These systems do more than just heat or cool. They dehumidify, filter, and exchange the air in sensitive zones at rapid intervals, ensuring a constant flow of purified, dry, temperature-stabilized air. Some areas, such as the seasoning tumblers or the vertical form-fill seal zone, may be isolated with positive air pressure to ensure that external air, dust, and contaminants do not seep into these critical zones. These environmental systems are integrated with digital controls that feed data into the facility's central monitoring hub. Temperature and humidity data are tracked every few seconds, and if any reading moves outside of pre-programmed tolerances, automatic alarms notify technicians to investigate immediately. In some cases, the system will even halt upstream processes automatically to prevent production under unsuitable conditions, protecting product quality. While environmental controls maintain external conditions, another system ensures the quality of what's happening on the line, inline quality assurance, and real-time analytics. Throughout the Cheetos line, from extrusion to bagging, dozens of sensors, scanners, and cameras work in unison to gather data on key quality metrics. These include moisture content, oil absorption rate, puff size, color uniformity, seasoning coverage, and weight per unit. Each of these factors contributes not only to taste and mouthfeel, but to customer satisfaction and regulatory compliance. Advanced laser micrometers and stereo imaging cameras measure the dimensions of each puff as it moves across the line at high speed. If puffs fall outside the programmed size range, either due to inconsistent extrusion pressure, die blockage, or improper cutting, those units are flagged and rejected automatically using pneumatic diverting arms. Simultaneously, optical sensors inspect the color of the fried puff to confirm it matches brand-specific targets. Color variation could indicate improper frying time, fluctuating oil temperature, or oil degradation. The system will trigger alerts or shut down sections of the line if it detects drift from acceptable limits. Another important part of inline quality is the metal detection system. Every snack must pass through high-sensitivity metal detectors or, in some cases, X-ray systems just before packaging. These devices scan for trace amounts of ferrous, non-ferrous, and stainless steel contaminants which could originate from worn machinery parts, upstream, or during maintenance. The sensitivity of these machines is such that they can detect metallic particles smaller than a millimeter in diameter. If a contaminated bag is identified, it is automatically ejected from the line, recorded in a digital log, and sent for root cause analysis. In high-output snack manufacturing, product changeovers are another critical concern. A single plant might produce multiple Cheetos variants, classic cheese, flamin' hot, jalapeno cheddar, and limited editions, on the same line, sometimes switching several times per day. To avoid cross-contamination of flavor profiles and allergens, the factory must execute a full product changeover, which includes both physical and procedural steps. The final bags of one variant are run through the line until the seasoning and product types are completely cleared. Following that, dry cleaning and wipe-down protocols are enacted on exposed surfaces. In flavor tumbler zones and powder feeding systems, residue removal is handled by a combination of mechanical vacuums, compressed air nozzles, and in some cases, wet cleaning cycles. Pipes carrying seasoning powder are often disassembled and cleaned manually or flushed with air-driven pigs, foam or rubber projectiles that scrape the interior of the tube clean as they are propelled by compressed air. All cleaning steps are verified through ATP, adenosine triphosphate, swab tests or allergen-specific strip tests to confirm the line is ready for the next product. Equipment cleaning and sanitization extend far beyond changeovers. Each section of the production line is scheduled for deep cleaning on a regular basis, with some components cleaned daily, others weekly, and critical systems, like oil fryers, undergoing monthly shutdowns for intensive maintenance. Every cleaning task is documented in a digital sanitation log that includes time-stamped photos, chemical usage records, technician ID, and verification by a supervisor. This log ensures compliance with food safety regulations and internal auditing systems. Speaking of oil fryers, one of the more maintenance-intensive systems in the Cheetos plant is the oil management setup. Used frying oil is constantly cycled through multi-stage filtration systems that remove fine particulates and oxidized residues. Inline sensors monitor oil color, free fatty acid content, and total polar compounds, all indicators of oil degradation. When thresholds are approached, fresh oil is introduced, and a portion of the old oil is purged to waste recovery tanks. This spent oil is not discarded haphazardly. Instead, it is captured and sent to third-party processors who refine it for use in biodiesel production or industrial lubricants, creating a closed-loop waste management process that supports sustainability goals. Seasoning systems have their own challenges in terms of dust and waste control. Cheese powder and spice blends are notoriously airborne, so extraction hoods fitted with HEPA filters are positioned above tumblers and conveyors to capture stray particles. These systems not only keep the air clean for workers, but also prevent buildup on surfaces and reduce cross-contamination risk. Powder recovered in this way is not reused in production, but is collected and weighed for waste tracking. Many factories monitor seasoning powder yield versus usage to optimize application and reduce excess without compromising flavor intensity. Additionally, factories employ floor-level waste segregation systems, where organic waste, such as broken puffs or overcooked batches, is separated from packaging materials and cleaning byproducts. Organic snack waste is often sent to animal feed processing plants or used in anaerobic digesters to generate energy, while plastics are compacted and shipped to recycling partners. These systems not only reduce landfill usage, but also lower the facility's total environmental impact per unit of product. Every phase of the factory's operation is governed by a robust system of documentation and auditing. Real-time production data is logged into the Manufacturing Execution System, MES, which connects to the plant's Enterprise Resource Planning, ERP, platform. This system allows plant managers to track every batch of Cheetos from cornmeal input to palletized output. If a quality issue is flagged post-distribution, every input, cornmeal batch, oil lot, seasoning blend, even the operator ID can be traced within seconds. This level of transparency is essential for large brands that operate under continuous scrutiny from regulators, retailers, and consumers alike. All these systems, from the air handlers and fryers to the conveyors and flavor blenders, are monitored by a central control room staffed by trained process engineers and operators. The control room acts as the nerve center of the factory. Touchscreen interfaces display real-time data on line performance, yield percentages, waste figures, and energy usage. Alarms and alerts notify the team of any deviation in pressure, temperature, fill levels, or machine health. The staff can make remote adjustments, schedule maintenance tasks, and even initiate partial or full shutdowns directly from their stations. In many facilities, predictive analytics platforms are integrated into these systems. Using machine learning algorithms, these platforms analyze historical and current data to forecast when a component might fail, how yield might shift under ambient changes, or what impact a change in oil temperature might have on puff expansion. This allows for proactive decision-making, reducing downtime, and maximizing efficiency. The manufacturing journey of Doritos begins long before the chips ever hit the fryer or the seasoning drums. It starts in the cornfields. Doritos use a specific variety of whole kernel yellow corn selected for its starch content, moisture levels, and particle uniformity after grinding. The corn is harvested at peak maturity and tested for aflatoxins, foreign material, and protein content before it's even accepted at the plant. Only corn that passes this first round of quality standards is brought in for processing. At the factory, truckloads of bulk corn arrive daily and are funneled into underground receiving pits that use gravity to guide the kernels onto conveyor belts. These conveyors feed the kernels into the first stage of preparation, the cleaning and sorting system. In this system, the corn passes through an array of vibrating sieves, rotating drum sifters, and powerful pneumatic air classifiers. Large debris like cobs, sticks, or stones are removed first. Then, finer contaminants like dust and small broken kernels are extracted using aspirators that draw away lightweight particles. Magnetized rollers also scan the corn flow to remove any traces of ferrous metal, ensuring total cleanliness before cooking. Once cleaned, the corn moves into the nixtamalization phase, a crucial and traditional process that transforms the flavor, texture, and nutritional properties of the corn. Nixtamalization involves cooking the whole kernels in a large stainless steel vat of hot water mixed with food-grade calcium hydroxide, also known as slaked lime. The corn is cooked at around 85 to 90 degrees Celsius for approximately 20 to 40 minutes, depending on the batch size and corn variety. This lime water solution serves several purposes. It breaks down the outer pericarp of the kernel, making it easier to grind and digest. It also increases the bioavailability of niacin, softens the internal structure of the corn, and imparts the distinctive flavor profile that Doritos are known for. After cooking, the corn is not immediately processed but left to soak, usually for 8 to 12 hours in the same solution. This extended soaking allows the lime to fully penetrate the kernel and continues the softening and flavor-enhancing process. After the soaking phase, the corn is drained and rinsed thoroughly in large industrial washers that spray it with jets of clean water while gently tumbling the kernels. The goal is to remove the loosened pericarp, excess lime, and any residual cooking liquid. What remains is called nixtamal, a soft, pliable corn mass that still holds the shape of whole kernels, but has a meaty, hydrated texture. The nixtamal is now ready to be ground into masa, the dough-like base of every Dorito chip. The grinding is performed using industrial stone mills, rotating horizontal stones made of volcanic rock or synthetic composites, precisely aligned to maintain a consistent grind size. The nixtamal is fed between the stones, and the pressure shears the softened corn into a dense, cohesive paste. This paste is the masa, and its texture is critical. It needs to be soft enough to press, but dry enough to hold shape without sticking. Operators continuously monitor the temperature of the mesa during grinding. Too much friction can overheat the dough, which affects the final chip texture. Ideal mesa temperature coming off the stones is around 45 to 55 degrees Celsius. Viscosity is checked using inline sensors that measure flow resistance, and if adjustments are needed, small amounts of water or return dry mesa are mixed back in using an automated feedback loop. Now, it's time to form the masa into flat sheets. The ground mesa is transported via auger screws into a sheeting machine, which extrudes the dough between two polished stainless steel rollers. These rollers are adjustable to control sheet thickness down to the millimeter, usually targeting between 1.2 and 1.8 mm, depending on the final chip specification. The mesa sheets are laid directly onto a continuously moving conveyor belt that carries them to the cutting station. The cutting system is a rotary die cutter, a high-speed drum outfitted with rows of equidistant triangular blades, each perfectly matched to the iconic Doritos shape. As the mesa sheet moves beneath the drum, the rotating blades stamp out thousands of identical triangle chips per minute. Each cut is sharp and precise, with just enough spacing to leave minimal waste dough between cuts. The trimmings, the thin slivers of masa between triangles, are not discarded. They are automatically lifted via vacuum collection and returned to the start of the sheeting process. These scraps are reincorporated into the fresh dough, ensuring efficient use of material and maintaining consistency. The cut triangle chips now move on a flat conveyor to a brief baking phase, which we'll explore in detail in the next section. This preliminary baking is vital to reduce moisture and stabilize the chip before it enters the high heat frying zone. But before any oil is introduced or seasonings are applied, this early stage, cleaning, nixtamalization, grinding, sheeting, and cutting, is where the foundation of Doritos' crunch, shape, and flavor truly begins. Once the precisely cut mesa triangles are formed and conveyed forward, they reach one of the most critical transitions in the Doritos factory, the pre-baking zone. Though often overlooked, this short but essential phase serves as a structural stabilizer that prepares each chip for frying without deforming, bubbling uncontrollably, or becoming overly saturated with oil. This stage controls the internal moisture content and builds the texture foundation that will result in the signature crunch. The masa triangles, still soft and slightly tacky from the sheeting process, move onto a continuous metal mesh conveyor belt that leads directly into an industrial tunnel oven. This pre-bake oven is not designed to fully cook or brown the chip. Instead, its primary goal is to reduce the moisture level from roughly 50% down to about 25 to 30%. This ensures the surface of the chip becomes firm enough to hold its shape when exposed to hot oil, but not so dry that it resists expansion. The oven itself is typically divided into multiple thermal zones. The first zone begins around 160 degrees Celsius, gradually increasing to about 260 degrees Celsius by the final section. Heated air is circulated by high-velocity blowers, creating a turbulent flow across the top and bottom of the chips to ensure uniform dehydration. The baking conveyor is made of stainless steel mesh that allows hot air to penetrate from below, guaranteeing that no side of the chip is undercooked. Sensors monitor humidity at various checkpoints, and real-time data is fed into the oven's PLC system to dynamically adjust airspeed and temperature depending on fluctuations in mesa density, ambient humidity, or line speed. As the chips exit the oven, they emerge firmer, drier, and more resilient, yet still pale in color and lacking the blistered surface texture that defines a finished Dorito. That transformation happens in the next stage, the continuous fryer system. Here, the par-baked chips fall gently off the oven belt and descend onto the infeed section of a massive open-surface fryer. The fryer itself is a high-capacity stainless steel vessel filled with continuously filtered cooking oil. Most Doritos production lines use either corn oil, sunflower oil, or a proprietary blend of vegetable oils chosen for their high smoke points and neutral flavor profiles. The oil is maintained at a stable frying temperature of approximately 180 degrees Celsius, with variations of only +2 GC allowed during operation. Chips are submerged in the oil for about 35 to 55 seconds, depending on their exact moisture level and thickness. The chips ride through the fryer on a submersion conveyor, essentially a mesh belt with downward pressure bars that keep the chips fully immersed while preventing stacking or overlap. This is crucial because the frying process is not just about dehydration, it's about vaporization. As the residual water inside each chip turns to steam, it forces itself outward, puffing the chips slightly and creating those micro blisters and bubbly textures on the surface. This internal steam pressure is carefully managed. Too little and the chip stays flat and hard. Too much and it balloons into a hollow pocket. Above the fryer, exhaust hoods pull away steam and vaporized oil particles, filtering them through a heat recovery system that can reuse waste heat to pre-warm incoming oil. This system conserves energy and helps maintain a cleaner frying environment. The oil itself is constantly recirculated through centrifugal filters and fine mesh screens to remove crumbs, starch residues, or burnt particles. Fresh oil is added in controlled volumes throughout the day to maintain chemical balance and replenish lost volume. Once fried to the optimal light golden color, the chips are lifted from the oil by an outfeed conveyor and immediately pass through a vertical de-oiling section. Here, powerful centrifugal blowers aimed at precise angles blast away excess surface oil. This keeps the chips crispy, prevents pooling in the packaging stage, and ensures that the seasoning will stick without creating grease buildup. The chips then pass through an ambient cooling tunnel to bring them quickly down to room temperature. Cooling is not merely for worker safety, it stabilizes the fat within the chip and prevents condensation when entering the seasoning drums. Now comes one of the most defining stages of the entire process: seasoning application. Each Dorito must carry the bold, vibrant flavor profile it's known for, whether that's nacho cheese, Cool Ranch, spicy sweet chili, or any of the dozens of global variants. The seasoning powder itself is a proprietary blend of flavorings, including real cheese powders, spices, salt, sugar, yeast extract, and encapsulated flavor oils that deliver controlled release bursts of taste. The chips are conveyed into a rotating seasoning drum, an inclined, slowly turning cylinder lined with food-grade stainless steel. As the chips tumble over one another, a dry powder dosing system mounted above the drum applies the seasoning using precision augers and dispersing nozzles. These nozzles can spray a uniform mist of oil if needed before the seasoning hits, which enhances adhesion for certain formulations. The rotation speed of the drum, the flow rate of the powder, and the incline of the system are all adjustable and carefully tuned. Too slow, and the powder won't distribute evenly. Too fast, and the chips may break, or the powder may collect unevenly on some sides. Optical sensors track the color and surface reflectivity of the chips as they exit the drum. If the reflectivity is too high, that could indicate under-seasoning. If it drops below a preset threshold, over-seasoning may be occurring. This live data is fed back into the controller, which tweaks the feed auger speed or pauses the oil spray accordingly. The seasoning drum is one of the most customized parts of the Doritos line. Different flavors use different particle sizes, densities, and oil volumes, which means the drum design and spray system must adapt depending on the product. Some drums include vibrating baffles or spiral lifts that increase tumbling action for extra thick chips or extra coarse seasoning. Once seasoned, the chips are directed into the weighing and bagging system, but before that, they undergo an automated inspection phase. High-speed vision cameras scan every chip for size, shape, and color. Broken chips, overly curled pieces, or visibly under-seasoned chips are removed via air-jet rejectors. These rejected chips are collected and sent either for regrinding or biomass energy use. Only chips that pass inspection enter the multi-head weighers, machines equipped with a dozen or more radial weighing hoppers. These hoppers constantly drop chips into a central collection bucket when the combined weight equals the target for each bag, typically between 28 g and 198 g, depending on package size. Once a precise combination is reached, the chips are dropped into a vertical form-fill-seal bagging machine. Here, continuous rolls of metallized polypropylene film are formed into tubes, sealed along the sides, and crimped at the bottom. The weighed chips are dropped into the formed bag tube just before the top is sealed and cut. Each bag is nitrogen flushed to displace oxygen, extending the product's shelf life and preserving crunch. Then, the bags are labeled, batch coded, and pass through a final metal detector before being boxed for palletization. After the freshly seasoned Doritos chips are individually weighed, bagged, sealed, and inspected, the production line moves into the critical post-packaging and logistics phase, where efficiency and traceability become as important as taste and texture. Though the chips are now fully formed and flavor complete, the operation is far from over. In fact, from a manufacturing systems perspective, the next stages, palletization, storage, shipping, and quality verification, are just as sophisticated and optimized as any in the earlier production line. The newly filled Doritos bags exit the form-fill-seal machines onto a series of conveyor belts designed to collect, orient, and organize them by SKU, bag size, and flavor variant. These conveyor lines merge into case packing stations, which use robotic arms equipped with vacuum suction grippers or gentle mechanical paddles to lift and place the chip bags into cardboard cartons. These boxes are pre-folded, glued, and printed with relevant product information, including product code, flavor, best before date, factory location, and a scannable QR or barcode that links to all production details. Each carton is inspected for weight and shape before it moves to the next phase. Even slight deviations in shape, caused by mispacked bags or an uneven number of chips, can disrupt downstream palletizing operations, so edge integrity and sealing quality are monitored automatically using high-resolution 3D scanning systems. Any carton that fails to meet dimensional tolerance is rejected from the main flow and rerouted for manual inspection or reboxing. Once cleared, the filled cartons are transferred to automated palletizing stations. In most modern Doritos factories, this process is entirely robotic. A multi-axis robotic arm lifts groups of cartons and stacks them onto wooden or composite pallets according to a predefined stacking pattern optimized for shipping efficiency and stability. These patterns are determined by a logistics algorithm that accounts for box dimensions, weight distribution, and the pallet's ultimate destination, whether that's a domestic warehouse or a long-haul overseas container. After each pallet is completed, a robotic stretch wrapper encircles it with several layers of clear plastic film to stabilize the load. A printed pallet ID label is affixed, containing detailed information about its contents, including product types, quantities, batch numbers, and destination. These labels are scanned into the warehouse management system, linking each pallet to the larger production database in real time. From here, pallets are routed into the warehouse zone. Doritos production facilities feature climate-controlled warehouses designed to maintain product quality throughout the storage period before distribution. These zones are not refrigerated, as Doritos are shelf-stable, but they are meticulously managed to avoid conditions that could lead to staleness or packaging deformation. Temperatures are generally held between 18-22 degrees Celsius, and humidity is controlled below 50% to prevent foil bags from absorbing moisture or warping. Inventory in the warehouse is managed by automated storage and retrieval systems. Tall racking structures are navigated by robotic cranes that pick and place pallets based on real-time demand, stock rotation policies, and shipping schedules. Each pallet's position in the warehouse is logged down to the specific shelf and column level, making retrieval highly efficient. The warehouse management system is integrated with the factory's enterprise resource planning software, ensuring that production and distribution are fully synchronized. While in storage, every pallet of Doritos is subject to randomized quality control sampling. A team of trained technicians removes sample bags from various pallets across shifts and production lines and sends them to a separate sensory evaluation lab within the facility. Here, samples undergo a series of tests: mechanical compression for bag integrity, gas analysis for nitrogen content, and oxygen intrusion, seasoning density checks, and most importantly, taste and crunch testing. Crunch is measured using a texture analyzer, a machine that applies controlled force to the chip and records resistance, fracture point, and acoustic feedback. The results are compared to golden standard reference chips to determine if the texture profile remains within acceptable limits. Seasoning adhesion and intensity are tested via flavor profile mapping, and every element from saltiness to umami to residual aftertaste is scored and compared against target values. If a trend of inconsistency is detected, an investigation is initiated, often leading to a review of upstream production parameters like fry temperature variability, seasoning drum throughput, or even ingredient batch variations. This closed-loop system helps prevent long-term quality drift and enables real-time course correction. Beyond the factory, the logistics infrastructure that gets Doritos from warehouse to retail shelves is another marvel of scale and precision. The factory works in tandem with PepsiCo's broader distribution network, which includes regional distribution centers, cross-dock terminals, and last-mile delivery nodes. Based on retail demand forecasts drawn from sales data, seasonal trends, and real-time POS metrics, shipment volumes are adjusted dynamically. This avoids overproduction and waste while ensuring retailers remain stocked. Each shipment of Doritos is accompanied by a digital bill of materials, which includes all traceability data from ingredient sourcing to packaging and palletization. This document allows not only for internal tracking, but also rapid action in the event of any product recall or customer complaint. If an issue is raised about a particular bag, say under-seasoning in a certain region, operators can trace the issue back to a specific lot, machine, shift, and even the original corn batch used in production. Globally, the manufacturing process for Doritos is also adapted based on regional consumer preferences and regulatory standards. While the foundational steps remain consistent: nixtamalization, sheeting, cutting, frying, and seasoning, the recipes and specifications can vary significantly. For example, in the US, cheese-based seasonings often use cheddar powder and lactic acid for tang, while in the UK or India, formulations may include less salt or alternative flavor enhancers to meet local guidelines or taste expectations. In markets like Japan or South Korea, where flavor sophistication and novelty are highly valued, factories produce limited edition Doritos featuring ingredients like wasabi, squid ink, or yuzu citrus. These variations often require changes in seasoning particle size, oil stability, or packaging material, and as such, the production lines must remain flexible. To facilitate this, Doritos factories use modular flavor dosing systems and quick changeover machines that allow seamless transitions between variants with minimal downtime. In addition to this flexibility, Doritos production lines are increasingly being outfitted with smart factory technologies. These include IoT sensors, predictive maintenance platforms, and AI-driven scheduling software. For instance, a vibration sensor might detect a subtle change in the seasoning drum's motor function that suggests a bearing is beginning to fail. Rather than waiting for a breakdown, the system automatically schedules maintenance during a planned production lull, avoiding unplanned downtime. Energy efficiency is also a growing focus. Waste heat from the fryers is often recovered through heat exchangers and used to preheat water for the nixtamalization tanks or warm the air in the seasoning room. Air filtration systems recycle hot air from the fryer exhaust into the building's HVAC to reduce natural gas usage. These sustainability practices help reduce both costs and environmental impact. Waste reduction is another area of innovation. Trimmings from mesa sheeting, broken chips, and seasoning dust are no longer treated as loss. Instead, they're collected, analyzed, and often reused in animal feed production, compost systems, or converted into biofuel at third-party processing facilities. Factory waste targets are set annually, and each production shift is scored on both yield efficiency and environmental impact. Ultimately, the journey of a Dorito from corn kernel to crunchy triangle is one of constant refinement. At every stage, whether it's dough hydration, fryer calibration, seasoning density, or robotic case packing, the process is governed by a matrix of mechanical precision and human sensory experience. The chips may seem simple to the average consumer, but behind every bag lies a production system that blends food science, industrial engineering, supply chain logistics, and consumer psychology into one unmistakable result: bold flavor, addictive crunch, and global brand consistency. It all starts with the consumer insight team, which continuously analyzes sales data, social media trends, cultural food movements, and even fine dining innovation to identify gaps or opportunities in the market. A spike in interest around birria tacos, for example, might inspire a spicy beef consommé Doritos concept. Once a viable trend is spotted, food scientists and flavor chemists work alongside marketing strategists to develop flavor direction briefs, detailed documents that outline the intended taste profile, emotional positioning, and target audience. In PepsiCo's Flavor Innovation Centers, teams begin with flavor mapping. This involves breaking down target flavors into their basic aromatic and taste components. For a concept like Flamin' Hot Dill Pickle, the scientists would analyze heat components, acidity, herbal notes, and salt balance. Using GCMS, flavor chemists extract and replicate aromatic profiles to ensure they match real-life foods as closely as possible. Next, benchtop seasoning blends are created in small batches using food-grade flavor powders, encapsulated oils, anti-caking agents, and natural extracts. These are applied to test chips using miniature tumblers that mimic the behavior of full-scale seasoning drums. Each test batch is evaluated by sensory panels, trained tasters who assess flavor intensity, balance, aftertaste, aroma, and how the flavor interacts with the chip's natural corn and oil base. Their feedback is mapped against a flavor wheel to identify gaps or off notes that require reformulation. Multiple iterations are often needed. Some spices may clump, certain acids might degrade in heat, and some flavor oils could lose their punch after just a few days in packaging. Stabilizers and carriers are used to protect volatile components, and microencapsulation techniques ensure that heat-sensitive ingredients only release during mastication, not while sitting in the bag. Once the flavor passes internal panels, the next phase is consumer testing. In select cities, Doritos organizes blind taste tests, sometimes with up to 500 participants per flavor. Reactions are scored not only on flavor, but on memorability, uniqueness, and potential repeat purchase behavior. Statistical modeling software crunches this data to identify the most promising formulas. When a flavor is approved, it must be scaled up to factory levels without losing its integrity. Seasoning blends are manufactured in industrial blenders, often in batches of hundreds of kilograms. The bulk seasoning is tested for particle size uniformity, moisture absorption, and flow behavior. During this phase, the seasoning is often reformulated slightly for stability, color consistency, and performance under high-speed drum tumbling. Then come the pilot runs. A limited quantity of chips is produced on a full-scale Doritos line using the new flavor. This lets engineers monitor how the seasoning behaves under actual production conditions, how well it sticks to the chip, whether it builds up on machinery, how the oil in the powder affects packaging line sensors. If issues arise, tweaks are made not just to the formula, but to the machinery settings as well. Finally, once all checks are passed, the new flavor enters full production, often accompanied by bold marketing campaigns and timed releases. Global coordination ensures that ingredients meet regional compliance, and new flavors often debut in test markets before rolling out broadly. These launches are tracked in real time, and consumer response loops back into the development pipeline, influencing which flavors stay, evolve, or disappear. This highly coordinated, scientific, and iterative approach allows Doritos to launch daring new flavors while maintaining the consistency and production efficiency that a global brand demands. Each new taste starts with creativity, but ends in finely tuned, factory-scale execution. Originally created by Barcel, a Mexican subsidiary of the Bimbo Group, Takis have grown from a regional novelty to a global snacking sensation. But behind each intensely flavored bite is a fascinating and highly engineered manufacturing process that brings together agricultural science, mechanical precision, and food chemistry on a massive industrial scale. To understand how Takis are made in a factory, we must begin at the very first stage, the sourcing of raw materials. The cornerstone ingredient in Takis is corn, more specifically, degermed corn flour, often referred to as mesa flour. This flour is derived from yellow or white field corn, grown primarily in the United States and Mexico. The corn used must meet specific quality parameters, particularly in terms of kernel size, moisture content, and starch composition. Contracted farmers typically grow this corn under strict agronomic practices to ensure high yield and consistent quality. Once harvested, the corn is transported to centralized milling facilities, where it undergoes a critical transformation. This transformation begins with the nixtamalization process, a traditional method that dates back to ancient Mesoamerican civilizations. In modern milling operations, dried corn kernels are steeped in a lime water solution, water mixed with food-grade calcium hydroxide at controlled temperatures for several hours. This chemical soaking loosens the hulls, softens the kernels, and alters the protein and carbohydrate structures, improving both flavor and digestibility. Once steeped, the corn is thoroughly washed to remove residual lime and loosen pericarp. What remains is nixtamalized corn, which is then ground through industrial stone mills or hammer mills into a fine, homogeneous masa dough. For Takis, however, the mesa is taken one step further. Instead of being used wet, as in tortilla production, it is dried and ground again into a shelf-stable mesa flour. This dried masa, now fine and moisture-free, serves as the primary input in the Takis production process. It's stored in massive silos within the factory, equipped with aeration systems to keep the flour dry and flowing freely. Pneumatic conveyors transfer the flour to precise metering hoppers above the mixing equipment. Here is where the transformation from flour to snack begins in earnest. The masa flour is dropped into high-capacity industrial mixers, where it is blended with water and a proprietary mixture of seasonings, emulsifiers, and sometimes oil. These mixers are equipped with temperature control systems and paddles designed to evenly distribute moisture throughout the blend. The goal is to create a pliable yet firm dough that is suitable for extrusion, a process that will ultimately define the iconic Takis shape. The mixed dough is conveyed directly to the extruder, a high-pressure, high-temperature piece of equipment that lies at the heart of many snack food manufacturing lines. For Takis, a twin-screw extruder is typically used. The dough is fed into the extruder barrel, where rotating screws push the material forward while simultaneously mixing, shearing, and heating it. Inside the barrel, steam pressure rises dramatically due to intense friction and controlled moisture. This heat gelatinizes the starches within the mesa, turning the dough into a malleable, semi-cooked matrix. At the end of the extruder barrel lies a die plate with specially engineered openings. These dies are shaped to produce flat ribbons of mesa with uniform width and thickness. As the dough exits the extruder, it experiences a sudden drop in pressure, causing it to puff slightly, though not excessively, as tacos are denser and more compact than puffy snacks like cheese curls. Automated blades then cut the ribbons to a standardized length, usually between 4 and 6 inches. Now comes one of the most recognizable steps in the process, the rolling. Using a synchronized series of mechanical arms and belt-driven rollers, each flat strip is quickly rolled into a tight cylinder, mimicking the appearance of a small, rolled taco or taquito. This is done at high speed, often in under a second per piece, with careful calibration to prevent unrolling or uneven shapes. The rolling units must operate with precise timing and alignment, as even small inconsistencies could result in defective product or downstream clogging. Once formed, the raw Takis are transferred onto a mesh conveyor belt that carries them into the continuous fryer. Unlike air-puffed snacks, Takis achieve their final texture and flavor through frying in hot oil. The frying process occurs in large stainless steel fryers filled with high-stability vegetable oil, typically corn or sunflower oil. The oil is maintained at a consistent temperature, usually around 350 degrees Fahrenheit, and is constantly filtered and replenished to maintain quality and prevent flavor degradation. As the Takis pass through the fryer on a conveyor, they cook rapidly, the exterior crisping while moisture evaporates from the interior. This gives Takis their signature crunch, dense and satisfying, with just enough resistance to offer a unique mouthfeel. The fry time is carefully controlled, usually around 30 to 60 seconds, to ensure even cooking without burning or excessive oil absorption. Temperature sensors, oil flow meters, and automated timing systems monitor every batch, with defective products automatically rejected by vision systems downstream. As soon as they exit the fryer, the Takis must be cooled rapidly to halt cooking and prepare them for seasoning. The hot snacks are dropped onto a vibrating cooling conveyor, which uses forced, ambient, or chilled air to bring their temperature down quickly. This conveyor system not only cools, but also aligns and spreads the product evenly, preventing clumping before seasoning. And this is where the flavor magic happens. Tacos are famous for their bold and intense seasoning blends, most notably the Fuego variety, which combines hot chili pepper and lime. The cooled snacks enter a large rotating tumbler or flavor drum, where they are coated with a fine mist of oil or flavor adhesive, such as maltodextrin or gum arabic. This light coating ensures the powdered seasoning sticks uniformly to the surface. Then, a precisely metered amount of dry seasoning blend is sprayed onto the rolling Takis within the drum. The tumbler rotates at a controlled speed, ensuring that every piece receives an even coating of the intensely red, flavor-packed powder. The powder itself is a carefully engineered blend of spices, acids, artificial flavors, and colorants, many of which are micro-encapsulated to preserve potency until consumption. This step is where flavor engineers shine, crafting bold profiles that hit the palate in waves. First, the citrusy tang of lime, then the slow-building burn of capsaicin from chili powder, followed by savory umami notes and salt. Once the Takis are evenly coated with their signature seasoning, the product advances to the post-seasoning inspection stage. Here, quality control takes center stage. As the finished snacks move down the conveyor belt, they pass through a combination of optical sorters, weight sensors, and human oversight stations. These systems are tasked with identifying any irregularities, broken pieces, improperly seasoned rolls, or foreign particles. High-speed cameras analyze each item against a programmed standard, with air jets used to automatically divert defective snacks from the production line. This meticulous approach ensures uniformity in every batch, both in appearance and taste. After clearing inspection, the freshly seasoned Takis enter the final phase of the production process: packaging. In large-scale manufacturing operations, packaging is not merely about enclosing the product in a bag. It's a tightly orchestrated, high-speed operation designed to maintain freshness, ensure food safety, and optimize shelf life. The cooled Takis are funneled into hoppers that portion them into individual servings. These hoppers are mounted above form-fill-seal machines, or FFS machines, which are the heart of the packaging operation. Each FFS unit starts with a continuous roll of multi-layered packaging film. This film is typically made from a combination of materials such as polyethylene, aluminum, and polypropylene. These layers provide essential barrier properties, keeping out oxygen, light, and moisture, elements that would otherwise degrade the snack's flavor and texture. The film roll is unwound, shaped into a tube, and sealed along its vertical edge using heat sealing bars. Simultaneously, the bottom of the tube is sealed to form a pouch, into which a precise dose of Takis is dropped from the hopper above. As the filled pouch moves through the machine, a horizontal seal is applied at the top, closing the package and completing the bag. The result is a perfectly sealed, shelf-ready snack pouch. Some facilities also inject an inert gas, typically nitrogen, into each bag before sealing. This process, called nitrogen flushing, displaces oxygen and helps prevent oxidation of the oil and spices inside the snack. It's a key technique in preserving freshness for weeks or even months after production. But the packaging line doesn't stop there. Once sealed, the Takis bags are conveyed to the labeling and coding station. Here, high-speed inkjet printers apply critical data to each bag, including production date, batch code, and expiration date. These codes are essential for traceability, enabling both the manufacturer and regulatory bodies to track products through the supply chain and, if necessary, initiate a recall. In larger factories, barcode scanners validate each print in real time, flagging any unreadable or incomplete prints for immediate rework. Next, the finished snack bags are grouped into larger quantities for secondary packaging. Robotic arms equipped with suction grippers or mechanical claws pick up batches of bags and place them into cardboard cartons or shrink-wrapped bundles. These secondary units are ideal for distribution to retailers, vending machine suppliers, and food service channels. Automated case erectors, packers, and palletizers handle this stage with minimal human intervention, ensuring consistency and speed. Once boxed, the cartons are scanned one final time, then transported to the warehouse using automated guided vehicles or conveyor systems. The warehouse itself is climate controlled, maintaining ideal conditions for snack storage, typically around 70 degrees Fahrenheit and low humidity. Inventory management systems track every pallet, integrating with enterprise resource planning software to coordinate distribution across multiple regions and customer channels. At this stage, Takis are officially ready for distribution. Depending on the destination, pallets may be routed to regional distribution centers, export facilities, or directly to major retailers. In the US, this typically involves refrigerated trucks or dry vans with temperature and humidity monitoring systems to ensure the product remains in peak condition throughout transport. For international shipments, Takis are loaded into containers and shipped via freight lines, with each load accompanied by customs documentation, certificates of analysis, and food safety verification records. It's important to note that all these stages, milling, extrusion, frying, seasoning, packaging, and shipping, operate under strict regulatory compliance and food safety protocols. The Takis manufacturing facility is typically audited regularly by health authorities and third-party certification bodies to maintain good manufacturing practices and adherence to standards such as the Global Food Safety Initiative, HACCP, or hazard analysis and critical control points is implemented throughout the line to identify and mitigate risks, from biological contamination to mechanical hazards like metal fragments. Metal detectors and X-ray machines are also integrated into the production line post-frying and pre-packaging. These systems serve as a critical control point, scanning every product to detect foreign objects that could compromise consumer safety. In the rare event a contaminant is found, the system immediately shuts down the line and activates traceability protocols, ensuring the source of the contamination is quickly identified and corrected. In addition to food safety, automation plays a crucial role in the consistency and scalability of Takis production. Modern factories are outfitted with CAD systems, supervisory control, and data acquisition, which allow operators to monitor and adjust every part of the process in real time. Temperature readings, fry times, dough consistency, seasoning distribution, packaging integrity, all of it is visible from centralized control rooms staffed by trained technicians. These systems also gather historical data, enabling predictive maintenance and process optimization over time. Moreover, the human element remains vital. Quality assurance personnel regularly conduct sensory evaluations to ensure the finished product matches the flavor, aroma, and texture profile that consumers expect. Samples are pulled at set intervals and subjected to detailed analysis, including moisture content testing, oil content analysis, pH measurements, and microbial testing. These assessments help maintain product consistency and detect any early signs of spoilage or variation. And let's not forget the environmental impact. Many modern snack food factories, including those producing Takis, are actively investing in sustainable practices. Waste heat from fryers is often reclaimed and used to preheat water or air elsewhere in the facility. Oil used in frying is filtered and recycled several times before final disposal. Packaging materials are increasingly being sourced from recyclable or biodegradable films, and energy-efficient motors and lighting systems reduce overall factory emissions. The success of Takis also hinges on innovation. Flavor development is a continuous process involving food scientists, sensory analysts, and marketing teams. New flavors are often trialed in small-scale batch lines within pilot plants, where formulation tweaks can be made rapidly without disrupting full-scale production. Once a new variety passes consumer testing, it's scaled up to the main line, where production parameters are adjusted to accommodate the unique characteristics of the new seasoning blend. In essence, every bag of Takis represents a fusion of ancient techniques and cutting-edge food science. From the Mesoamerican tradition of nixtamalized corn to the robotic arms and AI-controlled inspection systems of a 21st century factory, the journey from cornfield to snack aisle is a marvel of industrial engineering. The attention to detail, the layers of safety checks, the complex choreography of machines, and human oversight all come together to create that iconic crunch and fiery kick that snack lovers around the world have come to crave. Once the freshly sealed Takis packages leave the manufacturing floor, their journey is far from over. The next phase, post-factory logistics and storage, is just as critical to the integrity of the final product. From the moment those pallets are loaded onto the loading docks, every step must be meticulously orchestrated to maintain freshness, comply with regulatory requirements, and meet retailer timelines. Palletized shipments of Takis are typically staged in designated outbound logistics zones within the factory's warehouse. Here, inventory management systems, integrated with warehouse management software, guide automated forklifts or human operators in sequencing outgoing loads. Each pallet is tagged with RFID or scannable barcodes, providing traceable data like batch number, production date, customer destination, and handling instructions. This is especially vital in high-volume operations where hundreds of thousands of units move through daily. Distribution of Takis often begins with transfer to regional distribution centers, or RDCs, These massive hubs serve as strategic points between the manufacturing facility and the retail shelf. Transportation is conducted via trucks equipped with climate control systems to protect the product from temperature spikes or humidity, both of which could compromise the texture and flavor of the highly seasoned snack. Although Takis are non-perishable, they are still sensitive to environmental conditions due to the oil content and delicate nature of their fried, rolled structure. Upon arrival at RDCs, the pallets are unloaded and sorted according to their final destination. Some may be earmarked for export, requiring additional customs documentation and compliance with international food labeling standards. For domestic markets, the focus shifts to inventory allocation, wherein Takis are divided among retailers based on demand forecasts, sales trends, and marketing campaigns. Algorithms calculate optimal shipping routes and timelines to minimize storage time and maximize shelf life for consumers. In-store delivery typically occurs on a just-in-time basis. Retailers prefer to receive snack shipments shortly before they are needed for shelf restocking to reduce their own warehousing costs. Specialized delivery trucks make daily or weekly runs to supermarkets, convenience stores, gas stations, and even vending machine distributors. Each of these retail environments poses unique packaging and merchandising challenges, all of which were anticipated back at the design and branding stage of the Takis production cycle. One of the unsung heroes in the journey of Takis is the shelf life optimization strategy. Although the product is fried, which naturally reduces moisture content and microbial activity, the seasoning powders and oils are susceptible to degradation over time. To combat this, manufacturers employ a suite of preservation techniques. Nitrogen flushing, as mentioned earlier, displaces oxygen in the sealed package, but antioxidants like tocopherols or rosemary extract are often blended into the seasoning to prevent rancidity. Additionally, desiccant sachets are sometimes included in bulk packaging layers to absorb ambient moisture during long-haul shipping. Once Takis make it to the retail environment, product rotation and visual appeal become the next critical concerns. Merchandising teams work with stores to position Takis in eye-catching locations, often near checkout counters or in custom display racks. Packaging design plays a crucial role here. The vivid purple of the Fuego flavor, for instance, has become iconic. This is not accidental. It is the result of extensive consumer psychology research and competitive shelf analysis. The packaging is printed using high-intensity inks and UV-cured varnishes that resist fading under fluorescent retail lighting. Meanwhile, behind the scenes, the manufacturer continues to monitor product performance through various feedback loops. Point-of-sale data is constantly reviewed to identify hot-selling regions, seasonal trends, and underperforming SKUs. Social media sentiment analysis and direct consumer feedback also guide adjustments in flavor intensity, packaging size, and promotional strategies. All of this feeds back into the product lifecycle management software, which helps guide future production and flavor development decisions. Speaking of flavors, one of the most fascinating aspects of the Takis operation is the flavor innovation pipeline. Flavor development is not merely a matter of combining spices. It's a complex interplay of sensory science, market forecasting, and precision engineering. Within dedicated R&D facilities, flavor scientists and food technologists explore new seasoning blends that push boundaries while remaining accessible to a wide audience. Using a combination of gas chromatography, mass spectrometry, and trained sensory panels, they deconstruct flavor experiences into measurable data points. For example, developing a new flavor like Dragon Sweet Chili or Blue Heat begins with identifying flavor trends in regional and global markets. Are consumers leaning toward Asian-inspired profiles? Are younger audiences seeking spicier, more adventurous options? Once a flavor theme is chosen, food scientists begin formulating dry seasoning blends that meet those goals. These blends are then micro-encapsulated to maintain potency through the frying process, ensuring that the end product retains its flavor intensity after months on the shelf. Prototypes are created on small-scale extrusion and seasoning lines within pilot plants. Here, the entire Takis production process is simulated at a reduced scale. This allows for rapid testing of texture, color retention, seasoning adhesion, and oil interaction without interrupting full-scale operations. Multiple iterations may be required before the formula is finalized. Once approved, the new flavor is scaled up and introduced into the market through limited releases or promotional campaigns. Based on consumer reception, it may join the permanent lineup or serve as a limited time offering. But with every new flavor comes new challenges. Seasoning powders vary in density, oil absorption, and electrostatic properties, all of which affect how they adhere to the snack. The tumbler rotation speed, spray nozzle angle, and even drum temperature may need to be recalibrated to accommodate different blends. For spicy varieties, capsaicin levels must be carefully controlled not only for flavor balance, but also to comply with regional regulatory thresholds for spice labeling. Some jurisdictions require heat warnings if the Scoville rating exceeds a certain level. Furthermore, regulatory compliance is a continuous effort in every phase of production. Labels must accurately reflect ingredients, nutritional values, and allergens. In countries like the US, compliance with FDA labeling laws is mandatory. In the European Union, Takis must also adhere to FSA food additive regulations and translation requirements. This means each regional variant may have slightly different formulations or packaging to meet local standards. Another area of innovation is sustainability. Snack food factories around the world are under increasing pressure to reduce their environmental footprint. The Takis production chain is no exception. Some facilities have introduced biodegradable packaging options for select markets, while others have invested in solar panels and high-efficiency fryers to cut energy use. Spent cooking oil is now commonly collected and converted into biodiesel, and water used in nixtamalization is filtered and reused for non-contact applications like equipment cooling. Sustainability also intersects with supply chain ethics. Corn suppliers are vetted not only for quality and price, but also for compliance with labor and environmental standards. Supplier audits are conducted regularly, and digital traceability platforms are used to map the corn's journey from field to fryer. This level of visibility allows the manufacturer to ensure that every ingredient in a Takis snack aligns with their corporate responsibility goals. Takis, for all their fiery boldness and snackable appeal, are a masterclass in food engineering and global logistics. They represent what happens when cultural flavors are married with advanced manufacturing, when age-old ingredients are given new life through extrusion science, and when every detail, from the grind of the corn to the curve of the roll, is tuned for maximum consumer satisfaction. As the Takis brand continues to evolve, the role of emerging technology in snack production becomes increasingly pronounced. Digital twins, for instance, are now being introduced in advanced food manufacturing environments. These are real-time digital replicas of the physical production line, complete with sensors, predictive analytics, and machine learning algorithms. By modeling the entire extrusion and frying process digitally, operators can simulate how small changes in variables, such as dough moisture content, oil temperature, or seasoning particle size, will impact the final product before making physical adjustments. This minimizes downtime, reduces waste, and enhances consistency across batches. Artificial intelligence and machine vision systems are also revolutionizing quality control. High-resolution cameras paired with deep learning algorithms can now detect subtle flaws that human inspectors might miss, such as uneven seasoning, microfractures in the rolled snack, or variations in color that could indicate improper frying. These systems learn over time, refining their detection capabilities with each batch they analyze. This not only improves product quality, but also enhances traceability and accountability within the plant. One particularly forward-looking development is in the realm of alternative ingredient sourcing. As demand for gluten-free, vegan, and allergen-free snacks continues to rise, food scientists are exploring reformulations of Takis that use alternative flours, such as chickpea, lentil, or sorghum flour. These flours come with their own extrusion challenges, especially when it comes to texture and structural integrity. Specialized extruder screws and preconditioning treatments may be necessary to match the crispness and density of the original corn-based recipe. Flavor delivery is another frontier being actively developed. Microencapsulation technologies are growing more sophisticated, allowing for flavors to be released sequentially as the snack is chewed. This creates a dynamic sensory experience, perhaps a burst of lime, followed by a wave of chili heat, then a subtle, lingering smokiness. These multi-layered flavor profiles are tested rigorously in consumer panels and sensory booths, with metrics like aftertaste duration, palate burn intensity, and residual coating all logged and analyzed. All these innovations are feeding into a broader trend: personalization. The concept of mass-customized snacks, where consumers can choose their preferred heat level, flavor intensity, or seasoning combo, may soon become viable thanks to modular production lines and just-in-time mixing systems. Imagine entering a vending machine interface or online store where you could build your own Takis variant, which is then mixed and packed to order within minutes. Unlike traditional potato chips, which are sliced from whole potatoes and deep fried, Pringles begin life in the form of a dough. That's right, each Pringle is crafted from a carefully developed dough made from dehydrated potato flakes, corn flour, rice flour, and a precise mix of emulsifiers, oils, salt, and flavorings. This composition is no accident. It's designed for processability, uniformity, and that distinctive light, crispy crunch. The journey begins with sourcing and preparing the raw ingredients. Dehydrated potato flakes, the primary ingredient, are supplied by potato processing plants that convert whole potatoes into a dry, shelf-stable form. These flakes are produced by washing, peeling, cooking, mashing, and finally drying the potatoes into flakes through a drum drying or belt drying process. The quality of these flakes is critical. They must have consistent moisture, starch, and texture characteristics to behave predictably in the Pringles dough. In the factory's raw materials storage area, huge silos hold the potato flakes, as well as corn flour and rice flour. These are conveyed through enclosed pneumatic systems into high-capacity ingredient blending hoppers, where each component is dosed with incredible accuracy. Every batch of dough requires precision, down to the gram, to ensure the final product maintains the correct structural properties, color, and flavor balance. Ingredients are mixed in a horizontal ribbon blender or paddle mixer, often in batches of several hundred kilograms at a time. Water is then added gradually to the dry mix, and the entire mass is blended under tightly controlled conditions to form a malleable, uniform dough. The water temperature, mixing time, and total moisture level are all carefully monitored by PLC-controlled systems. The dough must be neither too dry, resulting in cracking during forming, nor too wet, which would lead to expansion or puffing during frying. Instead, the goal is a smooth, pliable dough with a clay-like consistency that can be shaped, cut, and fried without distortion. Once the dough is ready, it's transferred via conveyor to the sheeting line. This is where the process becomes highly visual and mechanical. The dough enters a series of rotating rollers, which press it into a continuous thin sheet, about 1 to 2 millimeters thick. These rollers apply uniform pressure across the width of the belt, creating a dough sheet that is even in thickness from edge to edge. Sensors above the belt continuously scan the sheet for thickness deviations, triggering automatic adjustments if needed. Next, the dough sheet passes under a rotary cutter, a drum outfitted with precision-engineered dies in the shape of the iconic Pringle oval. As the cutter rolls over the moving dough sheet, it cuts out uniform ovals, which are gently lifted off the belt using a vacuum system or pickup fingers and placed onto metal cooking molds. These molds are slightly concave to give the chip its characteristic hyperbolic paraboloid shape, often referred to as a saddle curve. Any leftover dough between the cutouts is collected by scrapers, rehydrated, and recycled back into the mixing process. This near zero waste approach is one of the key efficiencies of the Pringles process. It's also one reason the chips are so uniform. Every piece of dough goes through the same treatment again and again until it reaches the fryer. Once placed on the curved molds, the uncooked Pringles move via conveyor into the continuous fryer. This piece of equipment is massive, often stretching 10 to 15 meters in length, and filled with high stability cooking oil, usually sunflower or corn oil, heated to around 180 degrees to 190 degrees. As the metal trays holding the chips travel through the fryer, the dough crisps into its final form. Each chip is fried for a precise duration, usually between 10 and 20 seconds, to ensure it emerges golden, crispy, and with the exact moisture content required for long shelf life and a satisfying snap. Because the chips are held in molds during frying, they maintain their consistent curve and do not puff or fold. This gives them the clean, stackable quality that defines the brand. The oil used in the fryer is continuously filtered and topped up to maintain purity and minimize off flavors. Inline sensors monitor the oil temperature, flow rate, and chip throughput to keep the process optimized at all times. After frying, the chips pass through an oil drain section, often assisted by compressed air jets or vibrating conveyors that shake off excess oil. The chips are then conveyed to a cooling system, a multi-stage area where fans and ambient air bring the chip temperature down quickly but gently. Proper cooling is essential before flavor application. Too much heat and the flavor powders will degrade or fail to adhere properly. Once cooled, the Pringles are directed into the seasoning tumbler. This is a large, rotating stainless steel drum where chips are gently tumbled while dry flavoring powders are sprayed or sifted onto their surfaces. A light mist of oil may be reapplied before this step to help the powders stick. Seasoning can include classic salted flavors, sour cream and onion, barbecue, cheddar, or custom blends formulated in-house by flavor scientists. Each seasoning blend is composed of salt, acids, cheese powders, natural and artificial flavors, and sometimes even encapsulated aromas that release in the mouth. As the chips roll through the seasoning drum, every surface is coated evenly thanks to the drum's speed, angle, and baffle design, which keeps the product moving in a gentle, randomized pattern. The process is engineered so that not only is flavor distribution even, but breakage is kept to an absolute minimum. After all, uniformity is part of what makes a Pringle a Pringle. Once flavored, the chips proceed to the stacking station, a marvel of mechanical choreography. Conveyor belts equipped with sensors and robotic arms gently align the Pringles into neat vertical stacks, each containing an exact number of chips per tube. As the stacks are formed, they are transferred onto a platform that slides them into waiting Pringles cans, the brand's signature packaging that also serves as a structural support, keeping the delicate chips safe from breakage. As the neatly formed stacks of Pringles are guided toward the packaging area, we enter one of the most unique elements of the brand's manufacturing process: the creation and loading of the Pringles canister. Unlike traditional snack foods that use pillow bags or plastic trays, Pringles uses a rigid composite can designed to protect the delicate stacked chips from breakage and to maintain freshness for extended periods. The Pringles canister is a marvel of engineered packaging. It's made of composite cardboard wound into a cylinder with a metal foil-lined bottom and a plastic snap-on lid. Each element of the can is optimized for shelf life, stacking strength and brand identity. The inner lining of the can is coated with a thin layer of aluminum foil or a moisture-resistant laminate that acts as a barrier against humidity and oxygen, two of the biggest enemies of fried snack foods. The exterior, of course, is wrapped in a colorful printed label indicating the flavor, nutritional information, and branding. In the packaging area of the factory, canisters are assembled and formed on-site or delivered pre-formed, depending on production volume and facility layout. High-speed rotary machines apply the foil bottoms to each cardboard tube using a heat or adhesive sealing process. Once the bases are sealed, the empty cans are conveyed toward the chip stacking zone, where robotic systems are already preparing the next batch of perfectly formed chip stacks. With the chips cooled, seasoned, and stacked into uniform columns, a synchronized pusher arm aligns with the moving conveyor and gently nudges each stack into the open can. This is done with remarkable precision. Too much force and the chips will crack or compress. Too little and the stack may tip or shift inside the can. Every stack is composed of a standard number of chips, most often between 80 and 100, depending on flavor, region, and package size. Weight sensors downstream confirm each can's fill weight to verify proper loading. Next, each filled can passes through a nitrogen flushing station. This is a vital step in the preservation process. Before the plastic lid is applied, a short blast of food-grade nitrogen gas is injected into the can to displace any oxygen. Nitrogen is inert and doesn't react with fats or seasonings, making it ideal for extending the shelf life of fried foods. By eliminating oxygen, this step slows down oxidative rancidity, preserving the taste, aroma, and crunch of the chips for several months. Immediately after flushing, the snap-on plastic lid is applied. These lids are manufactured from injection-molded polypropylene or polyethylene and are flexible enough to form a tight seal without adhesives. In some cases, a foil pull tab seal is applied just below the lid for additional freshness protection or tamper evidence, especially for export markets or special edition products. Once sealed, the cans are rotated and conveyed through label verification systems, where barcode scanners and cameras inspect each label for alignment, print clarity, and proper coding. Date codes, production line identifiers, and batch numbers are printed on the can's bottom using high-speed inkjet or laser printers. These codes are crucial for traceability in the event of a recall, complaint, or audit. From here, the sealed Pringles cans are grouped into secondary packaging formats. Depending on the market and distribution requirements, this could include shrink-wrapped multi-packs, shelf-ready trays, or corrugated cartons. Robotic arms equipped with suction cups or pneumatic grippers stack cans horizontally or vertically into their assigned configurations. These groups are then passed through a heat tunnel to shrink-wrap them into a durable bundle, or they are placed directly into cartons for larger shipments. At this point, each grouping is staged for palletization. Robotic palletizers pick up completed cases and organize them into layered patterns optimized for space and stability. Each layer of cases is carefully aligned to minimize shifting during transportation. Once the pallet is fully loaded, it is automatically wrapped in stretch film and labeled with a unique shipping ID. This barcode ties the pallet to a digital inventory management system that knows its contents, weight, destination, and production timestamp. Before any pallet leaves the factory floor, strict quality control protocols are enforced. At multiple stages along the line, from dough mixing to packaging, line workers and QA technicians pull random samples for analysis. These samples are tested for moisture content using gravimetric or infrared drying methods, oil content using Soxhlet extraction or near-infrared analysis, color using colorimeters calibrated to Pringles' specific golden hue, breakage percentage by simulating drop and vibration tests, flavor uniformity through sensory panel evaluations conducted in specialized tasting booths. Each facility maintains a detailed product specification profile for every flavor. If any attribute, texture, taste, size, weight, falls outside these boundaries, corrective actions are triggered. This might include rebalancing the dough mix, adjusting fryer dwell time, recalibrating seasoning dispensers, or reprogramming stacking arms. In rare cases, product may be quarantined and destroyed if it fails microbiological or allergen controls. In parallel with physical testing, real-time data monitoring systems are constantly logging hundreds of variables across the plant. These include fryer oil, turnover rate, seasoning application rates, cooling tunnel temperatures, nitrogen pressure, and wrapping line speed. Plant operators access these through human-machine interface terminals, which are integrated with supervisory control and data acquisition systems. These tools allow live oversight of every critical process and make troubleshooting faster, smarter, and more proactive. Food safety is paramount throughout the entire operation. The plant is designed around zoning principles to minimize cross-contamination, meaning that raw ingredients, in-process dough, cooked product, and finished goods all move through different hygienic areas. Airflow systems, sanitation teams, and stainless steel equipment ensure compliance with GFSI, FDA, and ISO 20000 standards. Allergen controls, cleaning schedules, and traceability systems are regularly audited by third-party certification bodies. Meanwhile, sanitation and efficiency go hand in hand. After each production run or flavor change, the line undergoes a full clean-in-place procedure. Dough mixing vessels are flushed, sheeters and cutters are wiped down, seasoning drums are vacuumed, and oil is filtered or replaced. All maintenance events are logged digitally, and any anomalies in cleaning schedules are flagged for review. In terms of sustainability, the Pringles production system has also evolved. Cooking oil is now often recycled and re-refined after filtering. Off-spec product, chips that are broken, underfried, or misflavored, are collected and ground into animal feed or converted to energy through anaerobic digestion. Waste heat from fryers is repurposed to preheat incoming processed water. Even packaging waste from trimming labels or misprinted cartons is collected, baled, and sent to specialized recyclers. But sustainability doesn't stop at waste. Modern Pringles facilities are optimizing energy efficiency through LED lighting, variable frequency drives on motors, and smart climate control systems that adjust airflow based on production load. Water used for cleaning is recovered in greywater systems. Solar panels are increasingly being added to roofs to offset peak energy usage during day shifts. Through this carefully choreographed sequence of machines, materials, software, and sanitation, millions of Pringles cans are produced each day, all identical in shape, taste, texture, and crunch. From a seemingly simple snack emerges one of the most standardized and technically refined food production systems in the industry. A Pringle isn't just engineered for flavor, it's engineered for repeatability. As Pringles production ramps across continents, the factory processes remain largely uniform, but the flavors do not. While the foundational chip recipe is remarkably consistent from one country to the next, flavor development is where regional preferences and culinary creativity come alive. From seaweed in Japan, to paprika in Germany, to chicken tikka masala in the UK, the Pringles lineup is a testament to how food science adapts to global taste trends without compromising product structure. The development of new flavors starts at specialized flavor research and development centers, often housed within or adjacent to major production facilities. These flavor labs are equipped with pilot-scale processing lines that mirror the main production environment, but in miniature. Here, food scientists and flavor chemists experiment with combinations of spices, acids, aromatic oils, and flavor precursors, blending them into fine powders that can be dry applied or oil dispersed for coating. The process begins with a flavor brief, a document informed by market research, consumer data, and regional food trends. For example, in Southeast Asia, there's a growing demand for heat, umami, and fermented flavors, whereas North American markets favor bold, smoky, and cheese-forward profiles. Once the flavor direction is defined, formulation begins. This involves building the flavor in layers: top notes, middle notes, and base notes. These powders are then micro-tested in pilot seasoning drums using small batches of real Pringles. A cross-functional team of experts, including sensory scientists, marketing professionals, and regional representatives, sample the chips in structured sessions. Evaluations are made not only on flavor intensity and balance, but also on how the seasoning adheres, how it evolves during chewing, and whether it leaves any residual texture or off notes. To quantify this, descriptive sensory analysis is used. Trained panelists score each chip along standardized scales. For example, sourness, saltiness, umami, flavor longevity, and clean finish. These scores are matched against existing products and flavor targets to determine whether the new blend is viable. Adjustments are made repeatedly. A flavor might need more lactic acid for tang, less maltodextrin for stickiness, or more encapsulated compounds to preserve aroma during frying. Once a flavor passes these internal benchmarks, it's subjected to consumer testing. Often conducted in controlled booths or simulated living rooms, participants sample the chips blindly and provide feedback on liking, uniqueness, and purchase intent. Only the highest scoring candidates proceed to production scale rollout, and even then, factory adaptations are needed. New flavors may require adjustments in drum angle, rotation speed, or seasoning flow rate to achieve even coverage without waste or dust buildup. Interestingly, not all flavors can be produced on the same lines without risk. Facilities follow strict allergen management procedures. For example, cheese-based flavors often contain milk derivatives and must be run on separate lines or in dedicated shifts with full clean-out protocols between runs. Flavor dust may linger in filters or ducts, so cross-contamination risks are carefully managed through scheduling, deep cleaning, and validation swabbing. Once production begins, logistics take over. Distribution is a global operation. From factories in the US, Europe, and Asia, Pringles are shipped to more than 140 countries. The logistics chain is engineered to minimize time between production and shelf while protecting product integrity. Pallets are stored temporarily in automated storage and retrieval systems, massive, high-density warehouses controlled by software that manages FIFO protocols and precise temperature conditions. From there, transport trucks are loaded for regional delivery. In most climates, Pringles can be shipped in ambient dry vans as long as the temperature remains below 30 degrees Celsius. However, in hotter regions or during summer months, climate-controlled containers are used to prevent oil migration, flavor deterioration, or packaging distortion caused by heat. As a product reaches retailers, the packaging does more than just protect, it sells. The Pringles canister has undergone subtle yet meaningful changes over the years. Originally designed for durability and storage, it has been adapted for visibility and ergonomics. Modern designs feature bold color blocking, QR codes for promotions, and tamper-evident seals in some countries. In-store, Pringles are often displayed vertically to highlight their stackability, or horizontally to emphasize flavor variety. Multi-pack bundling strategies vary by region. In North America, shrink-wrapped tri-packs are common. In Europe, tray displays dominate, and in Asia, mini-can multi-flavor assortments are especially popular among younger demographics. Parallel to the consumer-facing systems, there's a silent but powerful force ensuring Pringles quality. Shelf life stability testing. In dedicated labs, accelerated aging chambers expose Pringles samples to high humidity, elevated temperatures, and UV light. These conditions simulate long-term storage to test how the chip's texture, flavor, and aroma evolve over time. Chemical analyses measure oxidation markers in the oil. Sensory panels check for flavor loss, stale notes, or rancidity. Packaging engineers also test barrier properties of the canister, evaluating oxygen transmission rates, moisture vapor transmission rates, and mechanical integrity. The rigid tube structure gives Pringles an advantage over bagged snacks in this area, but continuous improvement efforts focus on reducing material usage while maintaining performance. Sustainability teams investigate new liner films and lid materials to improve recyclability without compromising shelf life. Meanwhile, every Pringles manufacturing facility operates with a documented traceability system. If a single issue is reported, say a foreign object or off flavor, teams can trace the affected batch back to its raw material inputs, processing line, timestamp, and even the maintenance records of involved equipment. This level of accountability is not just for crisis management, it's also a pillar of continuous improvement under Lean or Six Sigma methodologies. Plant managers review key performance indicators daily, tracking metrics like yield efficiency, chip breakage rate, seasoning variance, and energy usage per ton of product. Teams hold daily Gemba walks, on-the-floor audits, where operators and supervisors jointly inspect equipment, cleanliness, and line balance. This close attention to detail helps ensure that every Pringle, from the first to the last in the tube, is as perfect as the brand promises. This dedication to operational excellence supports global expansion. In newer markets, Pringles are often co-manufactured with partners who undergo extensive onboarding and validation audits to match the parent company's process control standards. These partners receive the exact mold geometry, dough specifications, seasoning formulas, and quality test protocols to replicate the product faithfully, no matter where in the world it's produced. As the product circulates through global supply chains, consumer feedback plays an increasingly important role. Online reviews, customer service inquiries, and social media sentiment are continuously analyzed by AI tools that flag trends, positive and negative. If flavor fatigue emerges or a packaging flaw becomes evident, insights are routed back to R&D and production teams. In some cases, limited-time flavors are revived based on nostalgia or regional demand spikes, giving rise to special editions like Buffalo Ranch, Pizza Supreme, or Hot and Spicy Jalapeno. This agile, responsive production model allows Pringles not only to maintain its core consistency, but also to evolve. The ability to innovate at scale without compromising the chip's fundamental identity is a core part of its success. If there's one feature that sets Pringles apart from every other chip on the market, it's their shape, the hyperbolic paraboloid. This unique, saddle-like curve isn't just for aesthetics, it's a product of meticulous structural engineering, specifically designed to deliver maximum stacking efficiency, uniform frying, and a signature mouthfeel unlike any flat or crinkle-cut chip. The curvature allows each chip to nest perfectly into the next, eliminating air pockets and wasted space in the canister. This design minimizes breakage during shipping and provides the visual appeal of a clean, organized stack. But it goes deeper than logistics. The curve also impacts how the chip fractures during the bite. Unlike irregular chips that snap inconsistently, Pringles break with a clean, predictable crunch. This fracturing behavior is something food texture scientists study intensely, using acoustic and mechanical analysis. In fact, the crunch curve of a Pringle is measured by placing a chip under a pressure gauge fitted with sound sensors. The chip is compressed until it breaks, and both the pressure profile and the acoustic signature are recorded. A good Pringle has a quick, brittle break with minimal flex, translating into that unmistakable first bite sensation. If the chip bends too much before breaking, it feels stale. If it's too brittle, it shatters into crumbs instead of neat fragments. This attention to mechanical bite quality is supported by consistent thickness, oil content, and starch structure, all regulated at every stage of production. Even the dough's amylose to amylopectin ratio is fine-tuned during potato flake selection and mixing, influencing how the chip cooks, colors, and crisps. But beyond shape and sound, there's also the Pringles mouth melt. As the chip dissolves, the oil, salt, and flavor particles spread evenly across the tongue, engineered to deliver a balanced flavor wave. First salty, then tangy, then savory or spicy, depending on the variant. This progression is no accident. It's the result of controlled particle sizing in seasoning powders, fat coating mechanisms, and even saliva-soluble flavor compounds embedded in the chip matrix. The result is a snack that engages multiple sensory systems at once: crisp auditory feedback, light mechanical resistance, aromatic release, and lingering taste. This multisensory synchrony is a big part of why consumers find Pringles both addictive and oddly satisfying. It's also what makes them so instantly recognizable. Without even seeing the logo, people know they're eating a Pringle the moment they hear that first crunch. It all begins, unsurprisingly, with flour. Krispy Kreme uses a proprietary blend of enriched wheat flour, one formulated specifically for its lightness, protein balance, and ability to yield that signature fluffy bite. The flour is sourced from select mills that maintain tight quality control standards, ensuring the particle size, protein content, and gluten strength all fall within strict tolerances. Once delivered to the facility, the flour is stored in stainless steel silos under controlled temperature and humidity, preventing clumping and spoilage. Next, there's yeast, the biological engine behind the dough's rise. Krispy Kreme uses a commercial strain of baker's yeast known for its rapid activation, consistent fermentation profile, and neutral flavor. The yeast is usually delivered in refrigerated blocks or vacuum-sealed pouches to ensure maximum viability. Alongside the yeast, the other raw ingredients include non-fat dry milk powder, high-stability vegetable shortening, dextrose, salt, and water. Each of these ingredients plays a crucial role in shaping the final taste and texture of the donut. The shortening provides mouthfeel and moisture retention, while the dry milk lends a creamy undertone and enhances browning during frying. In the mixing phase, the ingredients are loaded into a spiral or planetary industrial mixer. The water is typically warmed to around 95 to 105 degrees Celsius before being introduced to activate the yeast. The mixer operates on a timed cycle, first gently combining the dry and wet components, then increasing speed to develop gluten and build dough structure. The dough is mixed until it achieves a smooth, elastic consistency with careful monitoring of temperature and hydration levels. If the dough becomes too warm, it risks overproofing, too cold, and fermentation is delayed. Sensors in the mixing bowl monitor the dough's internal temperature, moisture content, and even CO2 output to ensure consistency. Once the dough is formed, it enters the bulk fermentation phase. Giant stainless steel troughs, called dough rests, hold the dough as it ferments for the first time. During this period, the yeast metabolizes sugars and starches, producing carbon dioxide and ethanol. This expands the dough and begins developing its light, spongy structure. Krispy Kreme controls this step precisely, maintaining a temperature of around 80 degrees and 85% relative humidity in the proofing room. The dough rests here for approximately 30 to 40 minutes, depending on the batch size and ambient conditions. After bulk fermentation, the dough is transferred to a sheeting system. This is where things start to get visually impressive. The dough is rolled and flattened by calibrated rollers until it reaches a uniform thickness, typically between 10 to 12 millimeters. From here, it enters the cutting stage. A rotary die cutter stamps out perfect donut rings and holes in a continuous, automated process. The cutting dies are precision machined from stainless steel to ensure sharp, clean cuts and minimal dough waste. Any scrap dough is immediately collected by conveyors and reintroduced into the mixing system for reuse. Each donut ring now travels along a conveyor to the second proofing chamber, essentially a gigantic, climate-controlled cabinet lined with slow-moving racks. Inside, the donuts undergo their final proof, where they double in size due to continued yeast activity. The environment here is tightly regulated, around 90 degrees here and nearly 85% humidity. This proofing process typically lasts 30 minutes, but sensors embedded in the chamber walls adjust for ambient shifts in temperature or humidity, ensuring each donut achieves the perfect rise. Now comes one of the most mesmerizing parts of the process, the fry line. The fully proofed donuts are gently deposited into a continuous flow fryer using an overhead lifting mechanism that preserves their delicate structure. The frying oil, usually a high stability palm or soybean blend, is maintained at a precise temperature of approximately 365 degrees. Each donut floats along the surface, first frying one side, then automatically flipping at the midpoint using a mechanical turner. This results in the even golden brown exterior Krispy Kreme is known for, with a pale proof line around the center indicating proper fermentation. The frying process takes just under a minute per side, and the timing is crucial. Over-frying results in a dense, oily product. Under-frying leaves it doughy and structurally unsound. Oil filtration systems continuously clean and circulate the frying oil, removing carbonized particles and extending the oil's life while maintaining food safety. Once the donuts exit the fryer, they move onto a draining conveyor where excess oil drips away. The donuts are now fully cooked, but they're still bare, until they pass through the glaze waterfall. This is the stage most visitors at Krispy Kreme stores eagerly watch through the viewing window. The glaze itself is a proprietary blend of confectioner's sugar, water, and stabilizers, mixed in large heated vats to maintain fluidity. It's heated to a precise temperature to ensure it flows evenly over the donuts without soaking them. As the donuts travel beneath the waterfall, a curtain of glaze coats their entire surface in one smooth motion. The donuts continue to move along the belt for several feet to allow the glaze to set. During this time, cooling fans blow across the surface to speed up the crystallization process, giving the glaze its characteristic sheen and snap. At this stage, the original glazed donuts are complete. But not all donuts stop here. Many are diverted down alternate lines for filling, topping, or decoration. Filled varieties like custard, jelly, or cream-filled donuts are processed using pneumatic injection stations. The donuts are gripped and punctured automatically, and then a precise quantity of filling is injected into each center using calibrated nozzles. Topping lines include various enrobing stations for chocolate dips, icing drizzles, and even cookie crumb coatings, depending on the product line. Once decorated, the donuts pass through a final quality control checkpoint. Here, high-speed cameras, sensors, and human inspectors work in tandem to identify deformities, glaze coverage issues, or structural flaws. Any donut that doesn't meet the company's stringent standards is diverted and discarded or sent for animal feed, depending on local regulations. Now comes the packaging process. Original glazed donuts are usually arranged by robotic arms into branded trays or boxes, depending on the sales channel, whether destined for in-store display, grocery retail, or food service distribution. Boxes are barcoded, date-stamped, and sealed automatically. For freshness, Krispy Kreme relies on just-in-time manufacturing. Many facilities bake and ship multiple times per day, with some outlets even co-located within the production plant itself to reduce handling and delay. For external distribution, the boxed donuts are loaded into climate-controlled trucks equipped with racking systems that prevent damage during transit. These trucks make scheduled routes to retail locations, grocery partners, and kiosk outlets, often arriving just hours after the donuts were made. Once on site, employees stock the shelves or display racks, ensuring the donuts are sold within their optimal freshness window, typically less than 24 hours. Meanwhile, any donuts not sold by the end of the day are generally removed to preserve Krispy Kreme's reputation for freshness. In some regions, unsold inventory is donated to food banks or repurposed, while others adhere to strict disposal policies. Throughout this entire process, automation and precision engineering play a central role. From programmable logic controllers managing the mixing and proofing cycles, to machine vision systems inspecting glaze coverage, every step is optimized for consistency, safety, and speed. The machinery involved is custom designed, often proprietary, and requires teams of trained technicians to maintain. Clean-in-place systems are installed throughout the facility to sanitize pipes, mixers, glaze troughs, and conveyors between production runs. This minimizes downtime while ensuring compliance with food safety regulations. Every aspect, from microbial swab testing to allergen control and traceability, is monitored via centralized software platforms, which can track each batch of donuts from flour silo to store shelf. The story of every M&M starts with one essential component: chocolate. The heart of a standard M&M is a solid drop of milk chocolate, though other varieties, like peanut, almond, crispy, pretzel, or peanut butter, feature different cores. But regardless of the variety, the production begins in the chocolate refining department, where raw ingredients such as cocoa liquor, cocoa butter, sugar, and milk solids are blended to make a smooth, consistent chocolate base. The chocolate used in M&Ms is tailored for firmness and melt resistance, specifically engineered to maintain its structure during the coating process. Large stainless steel tanks are used to melt and hold the chocolate at controlled temperatures. Automated valves and mixers regulate temperature, viscosity, and flow characteristics. Chocolate destined for M&M production must be carefully refined to reduce particle size, usually to around 20 microns. This is done in multiple stages using equipment like ball mills, roller refiners, and conchers. These machines apply friction, pressure, and shear force to break down the solid particles until the chocolate achieves its desired mouthfeel. Once refined, the chocolate is pumped to depositors, automated nozzles that precisely dispense the liquid chocolate into molds or droplet-forming equipment. For the classic M&Ms, the chocolate is dropped onto a cool, rotating belt in small, round portions, forming button-shaped discs. These droplets are cooled rapidly using chilled air tunnels to harden them before further processing. The cooled chocolate centers are then collected and sent to the coating drums. These are large rotating pans, sometimes referred to as dragaze pans or coating kettles, where the hard candy shell is gradually built around the chocolate core. This is the heart of the M&M production process and one of the most visually striking steps in the factory. The coating process is a slow and incremental buildup, achieved by spraying a fine mist of sugar syrup onto the tumbling chocolate centers, then drying and hardening that layer before repeating the cycle. Each coating drum can hold hundreds of thousands of chocolate centers at once. As the drum rotates, a fine spray of syrup, consisting mainly of sugar and water with optional corn syrup, is applied in short bursts. Warm air is then blown into the drum to dry the layer, allowing the sugar to crystallize into a thin, hard shell. This cycle is repeated dozens of times, each time adding a microscopically thin layer to build up the final shell thickness.